Hello, everyone. So we were looking at Euler's method, and when we ended, I know none of you asked any questions, but I can imagine that you had several because it was like, what in the world are you doing? Okay, so basically, I started with the derivative, what we know to be the derivative of y. And I said, let's assume h is very, very small. Then we can say this is approximately without the limit. Then from here, I solve for y of x plus h, which is the value of the y at the next h. And I came up with this formula, y of x plus h is approximately y of x plus h times f of xy. And so what in the world is this used for? So I started with an example that I'm going to finish. So the example I started with was, here is the differential equation that you are given. The differential equation that you are given is always dy dx is equal to a function of xy. So let's just make sure we remember that from last time. So dy dx is equal to a function of x and y. And I will give you that y at some initial value x naught is equal to some value y naught. So that is the differential equation. Why is it called the differential equation? Does anybody remember why it's called a differential equation? Hello.
Is it because we differentiate?
Okay, I hear somebody talking. What did you say?
Is it because we differentiate?
Okay, that's close. It's called the differential equation because it's an equation that contains y and its derivative. Okay, so if we go back, we said a differential equation is an equation containing an independent variable x or t and a combination of a dependent variable and derivatives of that variable. If it only, so that's what makes it a differential equation, okay? So if it's a first order differential equation, it only contains y and its derivative. So we looked at these equations that here's y and x, the independent variable, and its derivative. Here is y and its derivative. Here is y and its independent variable t and its derivative. And then in equation 4, it is second order because it contains y double prime, but we're not going to solve those. So we're solving differential equations that contain y and its derivative. So I've given to you that dy dx is equal to f of xy. So that says here, f of xy is given by the equation y, just y. That's all it is. I gave you an initial value to start, y at 0 equals 3. So I know that at 0, y is 3. Now I'm telling you I want to find an estimate for y of 1, and I tell you what my step size h is. So that means knowing that my h is 0.2, my x's are going to go up to 1, 0, 0.2, 0.4, 0.6, 0.8, and then 1. Now, I can only go incrementally. So that means if I start at x naught being 0, then the next value of y I can find is when x is at 0.2. Then I have to use that to go on to find the next value at 0.4. Okay, so I had written over here my little formula. That is that y1 is y0 plus h times f at x0, y0. Once I know y1, I can then go on and find y2, because my formula, as we said, is yn plus 1. So the formula was yn plus 1, takes the old yn, adds to it h times f of the previous xn, yn. Okay, so for this problem, this is what we started with. Okay, so we start with x0. So x0 I'm going to use all capitals because it's only going to let me use capitals. So x0 is equal to 0, y0 is equal to 3. Okay, so now we need to compute f of x0, y0. Okay, so we know that y1 is going to equal y0 plus h times f of x0, y0. Okay, so what is that? Well, y0 we said was 3 plus, come on, plus h is 0.2, and f of x0, y0 is just y. Where do I know that from? Back here in the problem. Remember, f of x0, y0 is just the function on the right-hand side. So whenever I need to evaluate f of anything, so f of xy is just the function y in this problem. Okay, so therefore, where I need to multiply by f of, so this is f of x0, and that's just y. So I'm going to multiply by the y value, and the y value is 3. So I get 3.6. So now I can scroll back up here, and I know x1, let me put x1 in here, x1 is equal to 0.2. And now I know y1 says take y0 plus h times f0, y0, but there's no x0 in our problem. So this is 3.6. Okay. Now we need to find x2. So what is x2? Well, x2 is simply equal to 0.4. And y2 is going to be y1 plus h times f of x1, y1. I'll go back and put a times in here so you guys can see that. Okay, so now what is y1? Y1 is 3.6 plus h, which is 0.2, times f of x1, y1, but that's just y1, so that's 3.6. So I get 4.32. Okay. So that's what y2 is. Now let's find x3. X3 is just 0.6. I can see that from when I drew in what my X's were. So Y3 is going to be Y2 plus H times F of X2, Y2. Okay, so Y2 is 4.32 plus H, which is 0.2, times F of X2, Y2. But remember, F of X2, Y2 is just Y2, the same way if F of X1, Y1 was Y1 and F of X0, Y0 was just Y0. And the reason why is because F of XY is just that. So this is going to be times 4.32. And I get 5.814. Okay. What's X4? X4 is 0.8. Y4 is going to be Y3 plus H times F of X3, Y3. So Y3 was 5.184 plus H, which is 0.2, times F of X3, Y3, which is just 5.184. 6.208, 2208. So this is 6.20, I done forgot it already, 2208. Okay. And then the last one, which is the one I was trying to get to, which is Y1. I know that X4, X5 now, is now 1.0. So I am there. And then Y5 is going to be Y4 plus H times F of X4, Y4. So that's going to be 6.2208. That's Y4 plus H 0.2 times F of X4, Y4, but that's just 6.2208. And that's 7.4565. Okay, so that's my guess, my approximation for what my solution looks like. So if I were to plot that, so at 0, I am at 3. At 0.2, I am at 3.6. At 0.4, I am at 4.32. At 0.6, why am I being so stingy? Because I am. I'm at 5.81, so that's 5.8. That would be somewhere high. and that's at 0.8. And no, that's at 0.6. At 0.8, I'm at 6.2. So that might make me somewhere around here. And then at 1, I'm at 7.45. So I think this one might be a little high. Let me bring that one down a bit. So I can see that my solution kind of looks something like this. Okay. So that is my estimate for my solution. Okay. Let's try another one. So here's the problem. Solve dy dx is 2xy. Y at 0 equals 2. Okay. So let's say I want to find an estimate for y of 2 given h is equal to 0.4. Okay. All right, so now that I know h is equal to 0.4, I know that my points are going to go like 0, 0.4, 0.8, 1.2, 1.6, 2.0. So those are how my points are going to go. This is going to be x0, this one's x1, this one's x2, this one's x3, this one's x4. So basically I need to compute 5 iterates. Anybody have any questions about what I'm doing? I am solving this differential equation. It is a differential equation because I have y, an independent variable x, and the derivative of y. This is my initial value. I have to tell you where I'm starting from. I can start at 0. I can start at any value of x that you want to start or the problem gives you. Now this one says go to y equals 2, and they tell me h is equal to 0.4. So these are the increments that I need. So I need to compute 5 iterates to get there. Okay. So I'm going to do the same thing I did before. I'm going to draw a chart. So here's n, here's xn, and here's yn. So I know x0 is 0 and y at 0 is 2. So that's the value. Then when n is 1, I'm at x1, and that's 0.4. When n is 2, I'm at 0.8. When n is 3, I'm at 1.2. When n is 4, I'm at 1.6. And oh my goodness, when n is 5, I am actually, why don't I make this more interesting and say y of 2.4. So I'm not just doing, there we go. So now in order to get to 2.4, I need to do 6 iterates. Because I did 5 in the last problem. I want to do something different in this one. So this now goes to 2.0, and then to get to 2.4, I need to do 6. Okay. Any questions about what I'm doing so far? Okay, what is f of xy? Cameras on, guys. What is f of xy? F of xy. While you find that answer, I will take a roll. What is f of xy?
Are we solving for the next number?
We're not solving for x. I'm just asking you, what is the function that I'm going to use as xy in my formula?
Would it be the y1 equals y0 plus h? That one?
Okay, that's the formula to help me find. Okay, so that's a good start. Y1 is equal to y0 plus h times f of x naught y naught. I don't know what f is. What's f? Somebody help me. How do I find f? Okay. Ooh, y'all, let's go all the way back to oil before we did Euler's method, to the very beginning. And we said, we will be given a differential equation. Okay, Eli, I have to go back in and mark you present. Okay. Y'all still don't know what f of xy is.
Is it y prime?
Okay, we're getting somewhere. It's y prime. All right. So now that I know it's y prime, look at this picture right here, right here, right here. It says dy dx is equal to f of xy. Let's come down here to my problem. Dy dx is equal to 2xy. What is f of xy? Come on, people. Are y'all paying attention today? Okay, I'm gonna go back. Dy dx is equal to f of xy. Dy dx is equal to 2 times x times y. What is f of xy? Who honestly has no clue? Duanye, you said you don't have a clue? Okay. If the problem we're solving is dy dx is equal to f of xy, this is the problem that all the problems look like this. And I tell you that dy dx is equal to 2xy. What is f of xy?
That'd be 2x.
I'm sorry, say that again.
2xy.
2xy. Okay, so you have to be able to identify what f of xy is in every problem. In this problem back here, f of xy was just y. So in this problem right here, f of xy was just y. In this problem, f of xy is 2xy. Every problem you have to identify what f of xy is. Otherwise, you can't use the formula. Thank you, Donye. You are so very correct. So in every problem, you must identify what f of xy is. Because when I need to use that in my formula, if I don't know what f of xy is, I can't do my formula. Okay, the other thing I know I need is h is 0.4. Okay, so let's get going. x1 is equal to 0.4. Does everybody see that? Here's x1, 0.4. y1 is equal to y0 plus h times f of x0, y0. Okay, how do I compute that? Well, y0 I already know is 2 plus h is 0.4 times f of x0, y0 says take f of x0 is 2 times x0, which is 0, times y0, which is 2. So x1, y1 is also 2. All right, x2 is equal to 0.8. See, I'm here. x2 is, so I already did x1. Now I'm at x2. x2 is equal to 0.8. y2, uh-oh, I don't want to be there. y2 says take y1, add to it h times f of x1, y1. Okay, y1 is 2 plus h is 0.4 times f of, I should have put this in parentheses so maybe you guys would see it. Because this part is the f of. Okay, so this part right here was f of x naught, y naught. This was f of x naught, y naught. Now I'm going to add f of x1, y1. So f of x1, y1 is 2 times x1 is 0.4 times y1 is 2. So I get 2.64. Okay, so I have now found this, what this part here was f of x1, y1. Okay. Now I'm at here. Okay. x3 is equal to 1.2. y3 is equal to y2 plus h times f of x2, y2. So now y2 is 2.64 plus h 0.4 times f of x2, y2. So that's 2 times x2 is 0.8 times y2 is 2.64. 4.3296. Okay. Now we're going to x4. X4 is equal to 1.6. Y4 is going to equal y3 plus h times f of x3, y3. Okay, write down what that should be. Write down what numbers should go into that equation. And then I want somebody to tell me the numbers that go into the equation. Can somebody tell me the numbers that go in the equation, please? Who's the brave person that wants to give me the numbers that go into the equation?
You would put 4.3296.
Okay, whoops, I don't know wherever that wrote, I need to. Okay, 4.3296, good.
Plus 0.4
Plus 0.4
times 2
times 2,
times 1.2
1.2
times 4.3296.
times 4.3296. Anybody did not get that? Please let me know. Thank you, Danye. Yep. $8.486. Okay. X5 is 2.0. Y5 is equal to Y4 plus H times F of X4, Y4. Okay, somebody else. Tell me what goes into the next equation.
So would that just be 8.486?
8.486, 8.486. Okay,
Plus
go ahead.
0.4
Say that again.
plus 0.4
Plus 0.4
times 2
times 2,
times 1.6
1.6
times
times
8.486.
486. Good. $19.3481. Wow, that's big. Okay. Last one, x6 is equal to 2.4. Y6 is Y5 plus H times F of X5, Y5. Okay, somebody want to give me these numbers? Hello? Oh, I think somebody might have written it in the chat. Let's see. Okay, somebody started it. 19.3481 plus 0.4 times oh, I see it now. Okay, and that was, who was that? Dornier again. Okay, 2 times 2.0 times 19.3481. 50.3051, and we're done. Okay, so that is Euler's method. Any questions? Okay.